Okay, today I'm going to show you how to solve quadratics using what's called U substitution. So let's look at an example. If I have a quadratic equation x minus 4 squared minus x minus 4 minus 6 equals 0. Well, notice here I have two parentheses of x minus 4. So notice these are the same. Well, yes, I could FOIL out x minus 4 times x minus 4. I'd get a very long quadratic. So let's see if there's an easier option. Since I have the same parenthesis of x minus 4, let's let u equal that binomial x minus 4. So if we let u equal x minus 4, that means instead of writing our parenthesis, I'm going to write u. So this is going to turn into u squared minus u minus 6 equals 0. And that looks much easier for me to solve. So again, I'm just making a smaller quadratic. Well, this is a quadratic trinomial. How do we solve a quadratic trinomial? That is by factoring. So parenthesis, parenthesis. The only way to get u squared is u times u. And now I'm looking for two numbers that multiply to negative 6, but add to negative 1. Well, ways to multiply to negative 6 to add to negative 1 would be a negative 3 and a positive 2. Well, if something times something equals 0, we can use what's called the 0 property. And multiplying to 0 means that one of these is 0. So we're setting each parenthesis equal to 0. Isolate the u. So here on the left-hand side, I can add 3 to both sides. If I add 3 to both sides, u equals positive 3. If I subtract 2 from both sides, u equals negative 2. But I cannot box my answer because what? I found u. Remember, go back up here, let u equal x minus 4, right? Well, u, that means this left side is x minus 4. Because again, my goal is to find x. So if u, which is x minus 4, equals 3, or equals negative 2. Now I can solve for x. So I can add 4 to both sides. Add 4, add 4. 3 plus 4 is 7. X minus 4 equals negative 2. Add 4 to both sides. And x equals positive 2. So again, how do I know that my answers are correct? One way is I could graph. Remember, solving a quadratic equation means that you are finding the x-intercept. So I could graph this quadratic and find the x-intercept. So you should see that it crosses the x-axis at positive 2 and 7. And since it's a positive x squared, it should be an upward parabola. We could also plug in and double check as well. So another one. So what if I have, let's solve x to the 4th plus 95 x squared minus 500 equals 0. So here I have two ways I could solve this. Okay, way one. Way one is to solve this similar to being a quadratic. Okay, so since I have x to the 4th, this still is, in a way, a quadratic. Since I have a trinomial, again, I'm looking to factor, i.e. parenthesis, parenthesis. The only way to get x to the 4th, not the only way, but best way to get x to the 4th would be x squared times x squared. And then I'm looking for two numbers that multiply to 500, that add to 95. So I have a couple of different options to multiply to 500, 1 and 500, 2 and 250, 5 and 100, but 5 and 100, can I get 95 out of there? I can, with a positive 100 and a negative 5. Well, next I can use what's called 0 property. If I multiply to get 0, that means that one of these must be 0. So x squared plus 100 equals 0, and x squared minus 5 equals 0. Isolate to find the x, so I can subtract 100 on both sides. X squared equals negative 100. Square root. X equals again, square root of 100 is 10, but since I have negative, that means that I have an I. So this is plus or minus 10I. Add 5 to both sides. X squared equals positive 5. Square root both sides. X equals plus or minus square root 5. So again, here we are finding the x-intercepts. Notice that plus or minus 10I will not show up as an x-intercept, but it's still an imaginary root. But we should have this polynomial crossing the x-axis at positive root 5 and negative root 5. So that's one way to solve it. It is going straight to solving it like a quadratic. Way 2 would be using the substitution method. So let me show you how we can solve it using substitution. So notice we have x to the 4th plus 95 x squared minus 500. What if I notice that, I don't notice that I can actually factor it at parenthesis like a quadratic. So we could substitute and say, well, since this is x to the 4th and this is x squared, well, let's let u equal x squared. Well, if I let u equal x squared, well, how do I get x to the 4th? Well, that's just going to be u squared, x squared squared. So I'd have u squared plus 95. Well, what is x squared? X squared, we're now calling u. So now I do have a quadratic. U squared plus 95u minus 500 equals 0. I can now factor my quadratic trinomial, parenthesis, parenthesis. So again, only way to get u squared is u times u. I am looking for still two numbers that multiply to 500, negative 500, but add to 95. Again, those two numbers would still be positive 100 and negative 5. Next, I can use my 0 property. So u plus 100 equals 0. U minus 5 equals 0. I can solve and isolate the u, so subtract 100 from both sides. So u equals negative 100, and u equals 5. But no, I cannot box my answer. I'm not looking for u. I'm looking for x. Well, what did we let x equal? We're letting x equal, or u equal x squared. So instead of writing u, I'm going to replace that with x squared. So on the left-hand side, to isolate the x, I can square root both sides. And notice we still get the same answer, square root of negative 100. Because it's a negative, I have an I. Square root of 100 is plus or minus 10i. And square root. X equals plus or minus square root 5. So notice we get the same answer either way. I'm just showing you two different options. When we have x to the 4th trinomial, we could use substitution, letting u equal an x squared, or we could just factor as if it was a quadratic with a parenthesis, parenthesis.